and subtracting radicals. Adding and subtracting radicals. Okay, so again, I'm going to kind of like give you some steps, a procedure type thing to follow, and then hopefully if you need help when you go back to do the homework, you can look at this at these steps. Okay, so first things first. All right, in order to add or subtract radicals, they must be like terms. In order to add and subtract radicals, they must be like terms. Okay? So what does that mean? All right, well, they have to have the same variables with the same powers. Okay? You have to have the same radical with the same index and radicand. That means the stuff underneath has to match. Okay? So then what can be different? Right? The coefficients, those are the numbers in front. The coefficients are the only thing that can be different. Okay? So then how do we make sure, all right, that these things are like terms? Well, the first thing you have to do is simplify all radicals in the problem. You have to simplify them all, which is why we had to go over simplifying first. Okay, simplify all radicals. Then you are going to add or subtract only the coefficients of the like terms. Which means variables, exponents, radicals, and indices, that's plural for an index, stay the same. All right, so for our practice, come on. All right, for our practice, number one, I want you to put together 2 times the 4th root of 768 minus 3 square root of 20 plus 7 times the 4th root of 3. Now remember, the only way they can be like terms is if they have the same variables. Well, we don't have any variables in this one. I'm starting without letters, okay? But they have to have the same radical with the same index and the same stuff underneath. Do any of these match yet? No, that's why we have to simplify first. That's why we have to simplify first, okay? So, what does that mean? What does it mean to simplify? What are we essentially going to do with that 768? We're going to make it what? Everybody? Hopefully, we're going to make a factor tree. Come on, guys. Factor tree. All right, so I need two numbers. They multiply to be 768. Any two numbers. 8 and what? 8 and 96. All right. That's not the pair I picked, so I'm taking your word for it. Okay? All right, but we should all end up with the same prime factors. All right, what gives you 8? Okay, so 8's done, and 2 is done, but 4 goes a little bit further. Okay? How about 96? 3 and 32. So 3 is done, yes? But 32 keeps going into what? 2 and 16. 16 goes to 4 and 4. Another 2 and 2, 2 and 2. It is so important that you start crossing stuff out. Because when you get factor trees that have so much stuff, you got to make sure you know what you're allowed to circle. All right, we're circling sets of how many? How many of a kind? 4. So I've got a set there. Do I have enough for another set? Yeah, that's why it's important to keep track of everything. There's another set of 2's. All right, which means I get to take out 2 times 2, right? But there's already a 2 out front. So if I take out a 2 times 2, I get a 4. But then I have to multiply it by the 2 that's already in front for a total of 8. All right, and then we still have a 4th root. And what is the only number I did not circle for that one? 3. Okay? Then I have to start completely over with the one in the middle. Now, it's a square root. So when I break it down, I'm looking for sets of how many of a kind? 2. All right, so what's my piece in the middle going to end up looking like when I put it all together? I take out a 2, and I multiply it by what?
3.
All right, what kind of 3? Negative 3. So we get a minus 6, and what's left under the radical? 5. Thank you. All right, and then the last one, what do you notice about that one? The number inside is already prime, so I don't have to do anything with that one. I'm just going to bring it straight down so I can add. Okay, now I need like terms. Which ones are like terms? The first one and the third one. Because they have the same index and the same stuff under the radical. They have the same radicand. What part of it do I actually get to add or subtract? The number in front, the 8 and the 7. Well, what's 8 plus 7? 15. And then you keep the radical and the radicand and the index the same. That never changes. And then, of course, the piece that's not a like term is still part of my final answer. Questions? All right, let's try one with variables. Let's try one with variables. So practice number 2. All right, I'm going to put a 2b in front of a square root of 147 a to the 5th minus the 3a squared times the square root of 12ab squared. All right, just take a minute and simplify them. Don't think about like terms yet. You just have 2 pieces that you have to simplify. Okay? Okay, let's make our factor tree for 147. What did you guys find that went into 147? 3 and 49. Good. And then what gave you 49? 7 and 7. And that's it. Those are all prime numbers. Okay? All right. So we only need sets of how many? 2 to make a circle. So we definitely have a set of 7s. Okay, so I'm going to take a 7 out. What number is now in front? 14. Everybody know how we got that? Okay. Now, I have to look at my A's. I have 5, and I need sets of 2. How many sets of 2 can I make out of 5? 2, with 1 left over. So I'm going to take out 2 A's, and I'm definitely going to have 1 left over. And I'm just putting it in alphabetical order. So I could have left the B first, all right? But I'm going to put it second just because alphabetical order is typical. Not mandatory, just typical. All right, so then what goes back under? What all goes back under? 3A. And it is still a square root. Are we okay with that? All right, now let's look at the 12AB squared. All right, what's your factor tree for 12 look like? Good. And then 4 is a pair of 2's. Well, I need sets of how many of a kind? 2 again, right? All right, so I'm going to take out a 2. What is my new number in front? So we're going to have a minus 6. Can I take out any more A's? No. So that A squared just stays in front. Can I take out any sets of B's? Yes. How many sets? 1 set of 2. Are there any B's left over? No. So then what is left over? What goes back under the radical? 3 that I didn't circle, and that extra A. Now, in order to be like terms, if there are variables involved, all of the variables and exponents in front of the radical have to match exactly, and then all of the terms, everything under the radical has to match exactly. Okay, so I'm not talking about the 14 and the 6. I'm talking about everything else has to match exactly. Does it? Yes, and so they are like terms. But the only part you actually subtract are the coefficients. What is 14 minus 6? 8. Perfect. Everything else stays the same. Everything else stays the same. Done. Questions on adding and subtracting? So the key to those is simplify first, look for like terms, but you only add or subtract the coefficients. Questions? Okay. Next step, multiplication. Rolling right along. So multiplying radicals. Multiplying radicals. Okay, the key here, the one thing you have to make sure of, is that radicals being multiplied must have the same index. Must have the same index. That's the only criteria for multiplying. Okay? All right. So the number one step is to multiply first, then simplify. Well, that's kind of backwards from adding and subtracting, right? For adding and subtracting, you simplify first, then you add or subtract. For multiplying, you multiply first, then you simplify. Okay? So, what I mean by multiply, okay, you're going to see it in a minute, but you need to make sure you multiply coefficients. Those are the numbers in front. Coefficients in front together. All right, and then you multiply radicals together. You'll see what I mean in a minute. Okay? All right, you need to keep in mind the index does not change. And you may have to use the distributive property. Use the distributive property when necessary. All right, so here we go with some practice. And I'm just gonna jump right in the deep end. All right, 3 cube root 4p to the 5th times -2 cube root 14p to the 6th. Okay, so we're going to multiply first. All right, and anything that's in front of the radicals, that gets multiplied together and stays in front. All right, so that means 3 times -2 is what? Good. Then we keep the radical, the index the same, bring it down, and then we multiply the stuff under the radical together and bring it down. Okay? Well, what's 4 times 14? Thank you. And does anybody remember how to multiply letters? P to the 5th times P to the 6th. You add them. P to the 11th, right? You just add their exponents. Okay, so now it looks more like the problems we started with. Now you simplify. So you're going to break down the 56 and the p to the 11th and look for sets of 3. Thank you. All right, finish that one up for me. All right, what did you break 56 into? 8 and 7. Did anybody use 4 and 14? I mean, it started out as 4 times 14, right? So just keep that in mind. You don't have to go searching. Sometimes you can just use what you started with. And then let's see, 8 is 4 and 2. And then 4 and 4. I mean 2 and 2, sorry. All right, so I need sets of 3, yes? Do I have enough? of something? Yes. All right, so what does my number in front become? If I take out a 2, what does my number in front become? Negative 12. Thank you. All right, how many sets of 3 can I make out of those p's? 3. Good. All right, then you keep the radical with the index because there's leftovers. What is leftover? 7 e to the second. Very good. That's it. Good job. All right, let's make it a little bit harder. I'm not going to use letters, but I am going to put some addition and subtraction in there. We're starting to put it all together. So I have the square root of 8 times the square root of 2 minus 5 square root of 3. Thoughts? Thoughts? Anybody? Yeah, this is a distributive property. Okay, so we're going to take this square root of 8 and we're going to distribute it onto these two terms. Okay, so the pieces that are under the square roots get multiplied together. So 8 times 2 gives me the square root of what? Square root of 8 times square root of 2 gives me the square root of 16. Good. Then I can keep my minus sign. The 5 is going to stay in front of the next radical because there's nothing to multiply by it. Because you can only do radical times radical. And that's going to give me the square root of 24. Okay, so now I've turned it into a subtraction problem. So what's the first thing you have to do when you have an addition or subtraction problem? Simplify, then decide if you can put stuff together. Now, what's the square root of 16? 4. If you don't need to make a factor tree for that, you don't have to make one. Okay? Square root of 16 is 4. If you want to make a factor tree, you should still get 4. Okay? With no radical left over. All right, y'all want to know what y'all know what I'm talking about? All right, if I do this and go all the way to the ends, I have 2 sets of 2's. So I take out 2 times 2, but there's nothing left over. So it's literally just 4. All right, what do I do with the 5 square root of 24? What would give me 24? 3 and 8, 6 and 4, 2 and 12, lots of pairs. I mean, lots of options. All right, let's see, 2 and 4, 2 and 2. All right, so what am I going to take out of that radical? I have a set of 2's. All right, so what does my number in front become? Negative what? 10, thank you. And then what's left under the radical? 6. And they are not like terms. One of them has a radical, the other one does not. There is no chance that they are like terms. That's the final answer. Questions? All right, I got one more multiplication for us to look at, and then we can take another little break. Number 3. 2 square root of 3 plus 5 square root of 2, in parentheses, times 7 square root of 2 minus 4 square root of 3. Woo! Wow. thoughts? Keith, wake up there. What do you mean by factor? Yeah, double distribute. So we call that FOIL. That's our favorite four-letter F word, right? We're gonna FOIL this crazy thing. All right, that's just fancy terminology for double distribute. So we're gonna start with 2 square root of 3, and we're gonna distribute it onto these two terms. What parts are we allowed to multiply? The 2 and the the 2 in front here with the 7 in front, and then the 3 underneath with the 2 underneath. All right, then when we do the next one, the 2 in front goes with the -4 in front, and the 3 underneath goes with the 3 underneath. Okay, then we come back and we pick up the second term and we distribute it. So the 5 in front goes with the 7 in front to make 35. And the 2 underneath goes with the other 2 underneath to make the square root of 4. We will simplify in a minute. And then on the last one, 5 times -4 in front goes together. 3 times 2 underneath goes together. Now it's just a big addition and subtraction problem, right? So we simplify everything we possibly can, and then we look for like terms. All right, well, if I break down the square root of 6, do I get any pairs? Nope. So that's going to stay the square root of 6. So 14 square root of 6 stays. All right, how about the square root of 9? Does that have a pair in it? Yeah. So what do I do with that 3 that I'm going to take out? Well, good. Multiply by -8. So I get -24. And there's no radical on that one, right? All right, how about the square root of 4? Does that have a pair in it? Yep. What am I going to do with that 2? Multiply it by 35. I get 70 with no radical. And then we already saw in the first one the square root of 6 didn't have any pairs in it, so that one's just going to come down. All right, now I need to look for like terms. What am I going to be allowed to add together? All right, the stuff with the square root of 6 is considered like terms. What's 14 minus 20? Good. And we keep the radical. What about the other 2? Are they like terms? Yeah, they're just regular old constants. No square roots, no variables, no nothing. They're definitely like terms. What's -24 plus 70? Good. Now, is it possible, am I allowed to write the 46 first and then minus the 6 square root of 6? Would that be allowed? Yes, they are the same thing, so I just say that in case you see some multiple choice somewhere and they're backwards, it's still the same answer. Okay?